integrals. Just to warn you, well, perhaps show you, on the first page, there's a summary of the key results that we will meet. Now, please don't be freaked out about this because we're going to go through all of these results carefully and gradually as the pack resolves. At the moment, this is the only integration rule that you know. To integrate x to the n, you increase the power by 1 and divide by the new power. And it's worth bearing in mind that rule does not work when n is -1. So that requires n to not equal to -1 because then n plus 1 would be 0. All of the remaining rules we will cover during the purposes of this pack. So the first part of this is to do a recap of A1 integration. So the point of integration is twofold. So one application is if you have a situation where you're given the gradient function dy by dx for a curve and you want to find the original equation, because integration is the reverse of differentiation, you would need to integrate it. Now, what I'd like you to do is pause the video, have a go at question 1. This is an A1 integration question, and then I'll go through the answer in a minute. Okay, students, so here is my model solution to this first question. So if dy by dx is 3x squared plus 4x, y is going to be the integral of 3x squared plus 4x. You do not have to write it down with integral notation, but if you do, you put an integral sign at the first and a dx at the end. To integrate x squared, increase the power by 1, so it becomes power 3, and divide by the new power. So you get 3 over 3x cubed. To integrate 4x, it's 4 over 2x squared. You must remember to put a plus c. So therefore, the equation of the curve will have the form y equals x cubed plus 2x squared plus c. To work out the constant c, we can use the fact that the curve goes through the point 1, 5. Which is the same as saying when x is 1, y is 5. So if you substitute that into the equation, you'll get 5 is 1 cubed plus 2 times 1 squared plus c. That will simplify to give 5 is 1 plus 2 plus c. If you take away 1 and take away 2, you will get c is 2. So therefore, the equation of the curve in the form y equals f of x is y equals x cubed plus 2x squared plus 2. Okay, that's the first use of integration. The second use of integration is integration can be used to find the area bounded by a curve and the x-axis between two values on the x-axis. So here's question 2. Use integration to find the area of region R. So region R is the area bounded by the curve y is 3x squared plus 6 over x squared minus 5, and it goes from x is 1 to x is 3. Again, can I ask you to pause the video, see if you can remember how to do it, then I'll go through the answer in just 1 second. Okay, so here is my model solution to this. So what R is given by the integral of 3x plus 6 over x squared minus 5. Now 6 over x squared will need to be rewritten into a form where you can integrate it. It's 6 lots of 1 over x squared, so it's 6x to the power of minus 2. Then to integrate that, we increase the power by 1. So 3x becomes 3 over 2x squared. 6x to the minus 2 becomes 6 over minus 1, x to the minus 1. And a constant will always integrate to give the constant times x. Now, because this is a definite integral, you do not need to put a plus c. The standard notation is to put this in a square bracket now with a 3 at the top and a 1 at the bottom. Okay, and I'm just going to simplify that a little bit. So that is 3 over 2x squared minus 6x to the minus 1 minus 5x. That's because 6 over minus 1 is minus 6. Then, because it says justify your answer, you must clearly show that you have substituted in x is 3. So 3 over 2 times 3 squared minus 6 times 3 to the minus 1 minus 5 times 3. All of that take away, and both of these can go into brackets. 3 over 2 times 1 squared minus 6 times 1 to the minus 1 minus 5 times 1. If you carefully use your calculator to do that, you'll get -7/2, take away -19/2, which will give you a value of 6. Your calculator will do this in 2 different ways. It's worth remembering this, folks. So this is with the CG50. Other brands of calculators will do something similar. So to do the integral from the calculation screen, if you press Option F4 Calc, F4 Integral, and you do the integral of 3x plus 6 over x squared minus 5 between 1 and 3, you can just type that in and it will give you a value of 6. Or you can check it in graph mode. So if you go into graph mode and draw the graph of this function, so y is 3x plus 6 over x squared, whoops, something went wrong there, 6 over x squared minus 5. If you draw the graph, that's what you get. This is with the standard axes. I'm interested in the area between 1 and 3. If you press F5, F6, F3, and then integral, the lower limit value, if you type in 1, that will be fine, and then go to the upper limit value, type in 3, then it will shade in the area and say the area is 6. Now, please bear in mind, this gave you a positive value because the bit of the curve we are interested in is above the x-axis. If you have a curve where it is below the x-axis or part of it is below the x-axis, something slightly different happens. So this says use integration to find the area of region R. So R is the region bounded by the curve y equals x minus 4 in a bracket times 2x minus 3. Starting at some point A and some point B, it says justify your answer. So again, my friends, I'm going to give you, please pause the video. Please have a go at this question, then I will talk through a solution to this. Okay, so first of all, in order to do this, we're going to have to work out the limits we have to integrate between, which are the x coordinates of A and B. Now, because this is given in factorized forms, one of the factors is x minus 4, so one of the roots is where x is 4. The other factor is 2x plus 3, so the other root is minus 3 over 2. So this point must be where x is 4, and this point must be when x is minus 3 over 2. Then what I'm going to do is integrate the curve between these 2 points, and I know I'm going to get a negative value because the curve is below the x-axis. We will then remove the minus sign because an area has to be positive. So if I want to do the integral from minus 3 over 2 to 4 of x minus 4 times 2x plus 3, at the moment you cannot integrate any function which has brackets in. So the first step will be to expand the brackets. So integral from minus 3 over 2 to 4 of x minus 4 bracket 2x plus 3 is the same as the integral from minus 3 over 2 to 4 of, if you remove the brackets, you'll get 2x squared, you get minus 8x plus 3x, which is minus 5x, and minus 12 dx. Again, this is a definite integral, so integrate, increase the power by 1, divide by the new power, 2/3 x cubed minus 5 over 2x squared minus 12x between 4 and minus 3 over 2. If you then sub in x is 4, you'll get 2/3 times 4 cubed minus 5 over 2 times 4 squared minus 12 times 4. Take away 2/3 times minus 3 over 2 cubed minus 5 over 2 times minus 3 over 2 squared. Take away 12 times minus 3 over 2. If you carefully type this into your calculator, you get minus 136 over 3. Take a 181 over 8, which turns out to be minus 1331 divided by 24. But that's not my final answer. So the result is negative because the curve is below the x-axis. The actual area is the modulus of this, the positive value 1331 over 24. Now, again, you can check this by using your calculator. I'll just do it in graph mode. So the graph we were interested in this case was this one here. Y is brackets x take away 4 brackets 2x plus 3 And if you draw that, you'll see this, which is fine. I can go down a little bit if you want to make sure you've got all of the area in. That's okay. If you now press ding, 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 Gsolve F6 integral, there's various options here. If you use root, it will find the area between the x-axis between the roots. That's okay, root. So there's my lower limit, minus 1.5. Go to the right, there's my upper limit, and it will say the following. The integral is this thing minus 55.45, which is a decimal equivalent to the answer. The area is denoted by the green trapezium because the area has to be positive. Now, guys, one more. So that's all stuff we did before. The next question is a slight extension of what we did in AS Maths. So in AS Maths problems, you were given situations where you had to find the area between a curve and a line. In A2 Maths, you may be required to find the area between two curves. So this question here says the curves y equals x squared plus 1 and y is 11 minus 9 over x squared intersect at these 2 points. Use integration to find the exact area of the shaded region enclosed between the 2 curves. Now, guys, can I just be absolutely clear which graph is which? So y equals x squared plus 1 must be this one here, which means that y is 11 minus 9 over x squared must be that one there. Okay, now in order to do this, you will need to find or know where to start and finish your integration, which is likely to be where the curves fit or intersect. And they're telling you this in this question. Sometimes you might have to find this out. So what that means is this point here is where x is 1 and y is 2. This point here must be where x is 3 and y is equal to 10. So can I go through how I'm going to use integration to find out the area between these 2 graphs? So what I'm going to do is find the area between each curve and the x-axis, and then I will subtract them to get the area that I want. So perhaps I'll do this in different colors. Perhaps I'll do this one in red. So this, I can use integration to get, whoops, no, that's the other one, folks. That's the lower one. Let's get this right. Perhaps I'll do the other one in red. Okay, first one. So this one here I'll show in red. So I'm going to find the area under this curve, the top curve between 1 and 3. I can use integration to find that area there. And then when I've done that, I can use integration again to find the area under this curve. So that's going to be this shaded area here. And what I'm looking for is therefore the difference between those 2 areas. So let's do the one in red first of all. So let me do the integral from 1 to 3. It's only the x values we need of 11 minus 9 over x squared. Well, in order to integrate this, 11 is fine. 9 over x squared is 9 lots of 1 over x squared. So it's 9x to the minus 2 dx. Integrating that, 11 becomes 11x. Increase the power by 1 and you'll get x to the minus 1. Minus 9 divided by minus 1 is plus 9. No need for a plus c. Put it in square brackets with a 3 and a 1. So what this means is I have to do 11 times 3 plus 9 times 3 to the minus 1. Take away 11 times 1 plus 9 times 1 to the minus 1. It's absolutely fine to do these 2 bits on your calculator when you get as far as this. If you plug in x is 3 into this formula, you will get 36. If you plug in x is 1 to this formula, you will get 20, and 36 take away 20 is 16. So 16 is that red area we've worked out there. I'm now going to do the blue bit, which is the area under the other graph. So this is the integral. Again, you only need the x values from 1 to 3 of x squared plus 1 dx. which by straightforward integration is 1/3 x cubed plus x in a square bracket between 3 and 1, which is going to be 1/3 times 3 cubed plus 3, take away 1/3 times 1 cubed plus 1. Again, you can do these two things on your calculator. The first bracket will give me an answer of 12. The second one will give a bracket of 4/3. If you subtract them, that gives 32/3. So therefore, the shaded area which we are looking for is the area under the first graph, which is 16, minus the area under the second graph, which is 32/3. And that gives me 16/3 is the exact value. If you like, that's 5 1/3 is acceptable. Now, again, your calculator will do this. So if I draw the graphs of y equals x squared plus 1, and the graph of y is 11 minus 9 over x squared, if I draw them, I'll see this. Let me go up a little bit so I can see what's going on. That's okay. So I can see here the area that I am looking for. If I press, in this case, gsolve, integrate, I'm going to find the area between the intersections. The lower limit value, if you go to the right, is where x is equal to 1. Press execute. If you go to the right again, the upper limit value is that. It will give you that. The integral may be positive, negative, but the area there, 5.333 will go. Okay, folks, so that's mainly a recap of A-level A1 integration. The rest of this lesson will introduce you to some A2 rules.